This is a special request, and I hope it helps, okay? So, for problem number 1 on the review, for the amplitude, when you have to get the amplitude, all you have to do is look at the number that is in front of the function, which is sine, cosine, tangent, whatever it is. Yes. So the number in front of it is 4, it's -4. But when you get the amplitude, you're going to get the absolute value of -4. So the absolute value of -4 is just positive. So it's always positive. So it's just +4. So it's B. Okay. Number 2, the phase shift. There's 2 ways you can do this problem. And Shelby, you were asking me, is it -C over B? Yes, you can do that. But then somebody asked me yesterday. Nicole. Okay, Nicole
You can
said,
set it equal to 0.
can you set it equal to 0? And yes, you can also do that. So if you set it equal to 0, 6x plus pi over 3 equal to 0. You move the pi over 3 to the right, that becomes negative. So 6x equals negative pi over 3. And then to get rid of the 6, you just multiply by 1/6. And that gives you the phase shift, which is negative pi over 18. If you follow the formula, Shelby, that would be the C. In this case, is the opposite of this. So it would be negative pi over 3, and then divided by the B, which is 6. But see, this 6 is like 6 over 1, and that is the same thing as this right here. It's multiplying by the reciprocal of the 6 over 1. So it's both of them, one with the negative C over the B. The other one is just by solving for x, letting it equal to 0.
Where is phase shift in the equation?
Where what?
The phase shift?
The phase shift, the formula, negative C over B.
Where is it?
It's not like wait, what do you mean, on the graph?
The phase shift is always enclosed in parentheses after the sine, cosine, tangent, whatever it is. That's the phase shift. It's moved left or right. Yes, okay, so then the answer to this is A. Okay, number 3. For number 3 it says find the period of that function. Now it's cosecant. So for cosecant, secant, sine, and cosine, the 4 of them, the period is 2 pi over b. Okay, so it's 2 pi over b. And for tangent and cotangent, it's just pi over b. So b, in this case, is 6. So when you substitute the b for 6, the period is 2 pi divided by 6. Reduce that, that is pi over 3. And that's the period. So it's C. Number 4, vertical translation. The vertical translation, if you remember the sinusoid of the equation, let me just go back. Let me erase. Okay, so from the sinusoidal equation, that is y equals a sine of bx plus c and then plus d. The d is the one that is a vertical translation up or down. But in this case, they put in the d in the front. So it's -2. And that's the answer.
And whatever sign is attached to that gets...
Attached to it, like the a,
Yeah.
that
It
is,
stays
that's a
always?
stretch. If it's more than 1, it's a shrink. If it's less than 1, between 0 and 1. Okay, and the negative, if it's a negative, then that's a reflection. So it's not really applying to the A. A is a stretch or a shrink, vertical. Right. Okay, number 5, find the range. Okay, the range is the y values. So for cosecant and for sine, for cosecant and secant, it's from -infinity to the
Where it stops?
minimum of the inverse function,
So that one would be sine.
and then from the maximum of the base function to positive infinity. Right? So for this one is sine, that's right. And one way of remembering which is the inverse function or the reciprocal function is if it starts with a c, cosecant, then the inverse would be, or the reciprocal function would start with an s. And if it starts with an s, like secant, then the reciprocal function will start with a c, so it's cosine. Okay, so in this case it's cosecant, so it would be with the sine. So when you graph that sine, let me just do a little sketch of that. See, the sine graph is -6, so it starts at 0, and then 1, 2, 3, 4 marks. it goes down to negative 6, and then goes back to 0, and then up to 6, and then down to 0. So this is just the right. This is just the base function that you're using, right? And you have the asymptotes here. Every time it goes to the 0, that's an asymptote. So then that's right. So then it would be from negative infinity to negative 6, and then from 6 to positive infinity. So from negative infinity to negative 6, and then from 6 to positive infinity. And that's it. Okay? That's the range. Any questions so far? So far, so good? Okay. Problem number 6 is on the right. So let me go to the right. It says find the maximum and minimum of that. Okay, so then the maximum and minimum. This is just a stretch, right, or a shrink if it's a number in front. So negative 1/8, that's the amplitude, which means that that's going to give you the minimum and the maximum. So maximum value and minimum value. What's the minimum value?
The lowest point.
Negative 1/8.
Negative 1/8, the lowest point. That's right, negative 1/8. And then the maximum point would be 1/8. So then what's the answer for this problem? It's B. That's right. Okay. What about for number 7? What did you get for number 7?
C.
Letter C? Okay, let's see if it's letter C. Amplitude is 2. So the amplitude is 2. That is right. The period is pi over 4, and the phase shift is 1/4. Okay, first of all, I need to know the formula for the period on sine. So the formula for the period is P equals 2 pi over B. And I recommend that you write that first. And then substitute the value. Instead of P, go ahead and put pi over 4, because that's the period that is given. And then this would give you the B value. So you need to solve for B. So you cross multiply. This is pi B equals 4 times 2 is 8 pi. Then divide both sides by pi. So here B equals to 8. Then once you know that B is equal to 8, go ahead and put it into the formula for the phase shift. So phase shift formula is negative C over B. Right? And the phase shift given is 1/4. So let me substitute that. Phase shift is 1/4. Negative C, and I already know that B is 8. So let me substitute that. And then just cross multiply. So when you cross multiply, that is 8 equals negative 4C, then divide by negative 4, C equals negative 2. Then when you look at the equations, C has B to be 8, so yes, it's right, and the C, it's negative 2, so it is C. Good job, guys. Any questions on number 7? So far, so good? Okay. Number 8. So what was the answer for number 8? Letter C? Okay, let's take a look at that. Letter C. Okay, 1 tangent of x, that goes through the x-axis and the origin. So you're saying that 1 goes with C, that is right. Amplitude of half a pi, that is right. The second one, cotangent of x, has asymptotes at negative half a pi and half a pi. That goes with A. You're saying that 2 cotangent goes with A. Okay, 0, that's right, yes. And it's negative, that is right, yes. Number 3 is with B, negative tangent, so is passing through the 0, 0, the origin, but is reflected. So that would be B, that is right. Yes, good. And then D, that's right. So it is C. Great, okay, let's move on to the next. Okay, number 2. So here, all you have to do is multiply every x mark by 1/2. So that would be 1/2. And 1/2 of 2, that would be just what? It's just pi. So let me scratch this out. So it's negative 1/2. And this is just negative 1. Like that. Okay. And then it's a negative sign, so it starts at 0. Instead of going 1 up, it's going to go 1 down. And then up, and then down. And then it goes up, and then down, and then up. And this is going to be solid because this is a sine graph. I'm not using this as the base graph, like that. And that's it. As you can see, one period is represented in just one pi. Okay? So far, so good?
Sorry, I'm in the zone. Yeah, sorry. I'm
Okay.
staring at your face.
No problem.
Sorry.
Number 12. And number 12, this is a tangent graph, and for the tangent graph, it's supposed to be going through the origin or through half a pi.
The orange.
The origin. Tangent goes through the origin. Where are we going to have the asymptotes? At half a pi, negative half a pi, and half a pi. That's right. So I need to go to the negative half a pi and then draw my asymptotes. And now the graph's going to be passing through the 0, so. And now what about at 45 degrees? What's going to happen?
45 degrees.
Mm-hmm. Which is between 0 and half a pi.
It's gonna go like that.
It's going to go down because it's supposed to go to up 1, right? But because it's negative 3, it has to go down to negative 3. So you have to make sure you put that point at negative 3 and at 3. 3 and negative 3.
But it doesn't matter where on the x-axis, just as long as it's in between those asymptotes.
It's in between, right? That is right. Oops, I made a
Yeah, I was
mistake.
confused with that.
With where to put the point?
Yeah, like I knew it was between those 2 points, but I didn't know where.
Where to put the point, right? So it depends on the number. If you don't have any number there, that means that you have to go to up 1 and down 1. But if you have another number, then you have to go to that number. So, and now make sure that you do parabolas here, half of a parabola, and then a half of a parabola going like that.
Not a line.
It's not a line, no. So it's half of a parabola going up and another half going down.
But a regular tangent,
Uh-huh.
what would it go through?
It would be a regular,
Positive.
it would go like this.
But would it go through like a certain point? Do we
It
have to
would go
plot a
through
certain
1
point?
and through negative 1 because a tangent has an amplitude of 1.
Okay.
Yeah, that would be the regular one. But since this is negative 3, it
Mhm.
is stretched and it goes all the way to negative 3 and 3. Yes. Okay, number 13. For secant of 1/2, there's 2 transformations. The x has been changed, right? The all the x values are going to be multiplied by what?
2.
By 2, and the new x-axis is moved which direction? Down to negative 1. Okay, so let me go ahead and draw that. And which is the reciprocal function that I need to use here?
2.
The reciprocal function? This is secant.
Oh, sorry, cosine.
So I have to graph cosine, right? But dotted line. Okay, so at negative 3, I'm going to do my new x-axis.
It'd be at 0, right? 0, 0.
Oh my God, 10% battery. Okay, I hope it lasts. Okay, so multiply by 2.
Oh, I have a chart. You can do it.
But she can't project it.
Mm-hmm. I can't.
Oh.
But thank you anyways.
Just
Let's
put
see.
it under the.
Let's see how
Under the-
this works.
Just keep going.
Okay, well, let's see if we can finish it up. After this is, let me see, is cosine. So cosine starts at 1, right? So I have to go up to 1 unit at the new x-axis, down, new x-axis, up. And that has to be a dotted line. Okay, x-axis. And every time the cosine passes through the x-axis, you're going to have an asymptote. Because that would be 1 divided by 0, and that would be undefined. So that's why it's an asymptote. Okay. And then you just draw the parabolas opening down. Half of it going up. Another parabola up here. And then another parabola going down, and half of it going up like that. And that's it. That's 13. Any questions?
It's cosine and cotangent that are on the pi, right?
Half pi.
Right. On the cotangent is on pi.
Yeah.
Yeah, and Tangent and cosine. No?
And
Cosine is the.
you mean
this
cosecant?
Oh, yeah, cosecant, there you go.
Right, cosecant and cotangent, yes. Okay, you guys, I'm sorry that I did not record, but make sure that you have the amplitude to be 3, because it goes to all the way to positive 3 and negative 3. And the amplitude is 1 pi, so that 1 pi, it's from negative half a pi to 1 pi. So this is just in case the period is 2 pi, but in this problem, the period is just 1 pi. So 1 pi, which means that b is equal to 1. So it's just 1 here, okay? Okay, let's move on. Next one. Last page. Okay, so on number 19, exact value. You want the measurement of the angle that makes sine to be negative 0.5. So isn't that negative 1 half?
Yes.
Right? Okay, so then when you sketch the triangle, sine, you don't use the second or the third quadrant. Sine is negative, so it has to go down. This is negative 1, this is 2. So what's the measurement of this angle?
Square root. Oh wait, that's sorry, that's 30.
That would be
30.
30, right? But since it's going down,
Negative.
that would be negative 30. And they want it in radians. So negative 30, or how many radians is
Pi
it?
over 6.
Negative pi over 6. So negative pi over 6. So it's C. Number 20, our cosine. So I need to sketch the triangle. Is cosine, so I don't use the bottom 2 quadrants. It's positive, so it's adjacent.
First quadrant.
It's on the first quadrant, so this is the square root of 3. And 2 is the hypotenuse. So then the opposite side should be
1.
1, right? So what's the measurement of that angle?
30.
That would be 30.
So it's
Positive.
Or pi over 6. And that's what the answer is. It's just A. Okay, number 21. Arc sine. So first of all, I need to get a triangle for the inside of the parentheses. So arc sine, I don't use the second or the third quadrant. Sine is opposite over the hypotenuse. So opposite, it's 1. Hypotenuse is 4. And in the morning, they were asking me, how do you find the missing side? By subtracting or by adding? Well, it depends. If you're missing the side, right, if you're missing the side of one of the 2 legs, you subtract. But if you're missing the hypotenuse, then you add. So here, we're going to be subtracting with the Pythagorean theorem, because it's 1 squared plus x squared equals 4 squared. So 1 plus x squared is 16. Subtract 1, that is 15. And then you get the square root of that. So x is equal to the square root of 15. So the missing side is the square root of 15. And then once you get the triangle, then you have to look at the whatever function they want you to get, which is cosine. Right. It's adjacent over the hypotenuse, right? So adjacent hypotenuse, that's right. So it's the square root of 5, square root of 15 over 4. So that is C. Okay, number 22. Find the exact value. Okay, this has to be an angle. So just a little clue here. If it's 1, square root of 2, or if it's a square root of 2, square root of 2, and 2, those 2 combinations are combinations of a 45, 45, 90 triangle. So when you draw this triangle, this is opposite over the hypotenuse, and it's arc sine, so I don't use any of the left side quadrants. Opposite, square root of 2, hypotenuse is 2.
45 degrees and then
That is right. So it's 45 degrees.
Wait, isn't it negative though?
Is that negative?
Yeah.
It is negative. Yeah. So I need to go down. So I go down. Okay, so it's negative, so it has to go down. Negative square root of 2. So then this is negative 45, because it's negative. So that would be negative pi over 4. So it's C. Great.
Oh, it's a pretty color.
And now, what about number 23?
They cancel out.
That's right.
it's
So
just negative 5 over
You were on that one,
Right.
Brenda.
And this morning, they were questioning each other. I bet you got that wrong, right? You got that wrong, right, guys? So be careful. If it's arc cosine, just cancel them out, and the answer is just whatever's inside the parentheses. So it's negative pi over 4. So please don't miss that one on the test. And then number 24, it's arctangent. No, arctangent. Okay, so arctangent. Let me see. This is 2 over 1. So when I draw the triangle, tangent, I don't use the left or the bottom. Left, up, top or bottom. Okay, opposite of the hypotenuse over the adjacent. 5%. I'm almost done. Okay, so opposite is 2. Adjacent is 1, not to scale.
So you
Okay.
cancel with the Pythagorean theorem, which gives you square root of.
And you add them up, right? That is right. So it's 2 squared plus 1 squared. And that would be 4 plus 1. And that is 5. And then you get the square root of that. So C is the square root of 5. Okay, so now that you have all the sides of the triangle, then you look at the picture, they want sine. So it's opposite over hypotenuse. So it's 2 divided by square root of 5.
But you have to cancel the square root.
You rationalize, and that is 2 square root of 5 divided by 5. And that is C. Are we done?
Yeah.
Yes, okay, great. Okay.
I just have a question.